Hello and welcome back to the Oxford Maths Livestream. Oxford Maths Admissions Test Livestream, what's the name of my show? Good to see you again. This is going to be all about sequences and series. My name's James, I'm the Admissions and Outreach Coordinator for Maths at Oxford. But today, I'm just someone who really wants to tell you about sequences and series. So that's the plan for the next couple of hours. And hopefully you're also going to tell me about sequences and series. You can join in live at slido.com with the event code MATLIVE. There's a link in the YouTube description or a link on the homepage for this experience that we're all having. He says links everywhere. I've tried to put links everywhere. Hi to Louis and Anonymous and Lala and is it? Who's moderating chat again? Is it? It is Pulak again. Hello to Pulak, current student who is moderating chat, who has just got a wave of people saying hello. Let's see how that goes. Oh, chat's extended into my zone. There we go. Not used to this. Yeah, neither am I. I've been doing this for years and I'm still not used to it. I'm going to put that there. I'll sort of have chat, a little bit of a gap above my head so that I can still have my face in every single frame. Gosh. Right, good to see you all. Hello, Ali and X and EJ, and the concept of category theory, and Anika and Jen. God, oh my goodness, right. I would like two things. I would like to give you some maths because we always start with the maths. And I'm going to start a poll for how was your day today? Aha! Someone's registered the username partial differential equations. Wait, did they just change it from category theory to partial differential equations? Attempt to switch from maths I don't know about to maths I do know about. Maybe. Oh, it's not all about me. Hello, Sophia as well. And some more anonymous people. Thank you, anonymous people, for reminding me that you can be anonymous. That's one of the reasons we're using Slido chat. And while we're having a look, I'm going to put the website. So there's a maths question. How many things can I fit on the screen at once? It's all of the things. Okay. There is a maths. Hey, this is fine. I just scroll that up a little bit. Can I put this in here? More of the things on the screen. Yes, this doesn't quite fit, does it? There is a website which is just making its way into here. I'm an idiot. I need to switch to this mode. Hey, brilliant. Okay, you got some maths. You've got a look at the website. Maybe this is where you came from. This is where you just were before you clicked through to YouTube. I'm really putting it up at the front of this video because I didn't do that last week, and several people asked me where they could get things like the worksheet, or the solutions, or a link to the live stream itself. Nobody asked for that. You've already got that, and that's where you are. People are having a great day. That's pretty good. Look at that, 5 stars is winning. So this is the thing that's got a direct link to chat. It's got information about what we're doing. It's also got the schedule. So if you want to look into the future, you can find out. I use this as well for tracking what I'm up to find out what I'm going to be talking about on the 16th of July. It's differentiation, can't wait. Also, some of these are links. So you can actually, for next week's session, you can have a look at what we're going to do in advance. I'm trying to put that up a week before. So today I published geometry and solutions. You might think it's a bit weird to publish all of the solutions before I've done the live show, but this is partly because you don't have to watch the live show unless you want to. The live show is supposed to be helpful if you want to ask questions, or if you want to have a chat, or if you just want a bit of background noise on while you're doing next week's question sheet, with chat saying, I also found that difficult. I don't know. These are all things that I think people might find useful about the whole thing that we're doing. Anyway, that's what we've got. We've also got links to other stuff, which I'm just going to promote on screen. There is a physics equivalent of this. If you are a physics person, or if you're doing ESAT, ESAT, there is a preparing for Oxford physics thing over here on the left. If you're a computer science person, you're in the right place, but also you might like CS specific things, so I've put some links down there. If you want to get even further ahead in the sense of seeing videos before I've made them, you can't see videos from the future, but you can see videos from the past on this archive thing in the middle. And we have links to Jane Street, who are graduate employers who I think it's pretty cool that they're supporting this show before you've even gone to university. They would like you to have heard of Jane Street. That's not the talking point. They have actual talking points, but I think they would like you to have heard of Jane Street, so that when you've done the whole maths degree thing, that you might think of that. Right, okay, let me go away. You know where to find that now, though. Everyone knows where to find that. Chat's having a wonderful day, which is lovely to see. How are we doing? We've got Paul Erdush in chat telling us about AI. Matthew's here. Hello, Matthew. Hello, Violet. Hi. Good, right. Okay, I think I've said hi to people. Right at the start, Louis asked a really good question about geometric progressions, which I'm going to try and remember to do. Louis asked the question, why are they called geometric series? What's geometric about them? We've got the whole geometry session next week. There is a really good answer, which I will try to remember to do at some point. Right. Okay. Good. Here we are. We've got a maths question on the board. I think the rules for these are basically that I give you a thing. This is binomial theorem, by the way. It's one of the things on the TMUA specification. Let me scroll a little. There you go. I'm just gonna hide chat so that we can read the whole row. So the specification says binomial expansion, and I find this slightly odd that they, in the content specification for TMUA, they call out two sorts of things that you might need to do a binomial expansion: 1 plus x to the power of n, and separately a plus f of x to the power of n, where some simple function f of x. So the one I've given you on the board, you see, I've been mean because this thing here is not a function of x. It's got x and y in there. Nevertheless, I think that you have either done this just fine, or you've made a small silly mistake, which I can't see and don't really mind about, or you're not really doing the maths. You're just here for the like background noise or something. Maybe you're waiting for me to get onto the questions that you have done because you have questions. Right. Okay. So I claim that you can multiply this out, even if that's not a function or a just x. That you can make this work. This might turn up in your life if you see something like without that helpful set of interior brackets, something like this. You might look at that and think, well, that's not binomial, that's trinomial. I need some sort of trinomial formula. But no, you don't. There is a trinomial formula. Trinomial expansion is a thing, but you definitely don't need to know about it because you can make do with what you've got. I love maths so much. You don't need all this high technology. You can just make do with what you've got. For example, I can treat x plus y as a single thing. My rule for this is pretty much I have 1 cubed plus 3 times 1 squared times whatever that is. It could be x, it could be f of x, it could be a, it could be just some object. I could give it a name, I suppose. I could say maybe call this. I love calling things u for my substitutions or something, and then it really is just a single letter. But I don't even think I need to. So you do this, and then of course the joke for this question is you're then doing it again. You're doing binomial expansions inside binomial expansions. And this is why I thought it would be a good warm-up exercise, forgetting briefly that I would have to do it myself. So here we are. So lots of terms here, multiplied by 3, of course, and then hopefully I get these terms right as well. Otherwise I'm off to a shaky start. That looks about right. Loads of terms. Broadly speaking, some terms that look like cubic terms. I count that as a kind of cubic term as well. I even count that as a kind of cubic term when I have x's and y's because the powers add up to 3. The exponents, sorry, add up to 3. Let's get the language correct. There's some quadratic terms. There's some sort of linear terms. Sort of got a bunch of stuff. Yeah, so you could use Pascal's triangle. Pascal's triangle is this way that people have perhaps of knowing what these mysterious numbers are. Let's color code things. The 1, 3, 3, 1. There is a 1 there secretly. Some people write out a little bit of Pascal's triangle, also known as Yankees triangle or Tartaglia's triangle, whatever. To be honest, I know 1, 2, 1 because I know x squared plus 2xy plus y squared. I have to be honest, I think I've memorized 1, 3, 3, 1 as well. Do I know the next one? Well, I've got it on screen now, so it's obviously 1, 4, 6, 4, 1, right? Maybe I know that one. I don't know. I'll have to try and catch myself out later to see if I've learned that one. Is there a general binomial expansion for this? Yeah, so there's a general thing called a trinomial expansion, which I'm trying not to talk about because I definitely don't think you should learn it. But if you're interested, then you could go and look up how to do this in general. You expect things like x cubed, x, y, z somewhere, y squared z. You could look this up, or you could work it out. I sort of back you to work it out. A clue, Pascal's triangle is a two-dimensional shape because binomial, there are two things. You will need some sort of tetrahedron, a three-dimensional thing for three things inside the bracket. Anyway, that's your clues. We could go and look it up if you like. Right. Yeah, so the alternative for those numbers is to use factorials, says the anonymous person in chat, where you know that this is something like the binomial coefficient 3 choose 1, which is 3 factorial divided by 1 factorial 2 factorial, which is 3. That's where that number comes from, I suppose. For the kind of fluency, doing things quickly, I think I would memorize the pattern 1 3 3 1, just like you've memorized the pattern, I'm sure, 1 2 1 for how to, if you have to multiply out this thing, x plus y squared, I'm sure you don't get out any factorials to work out what the term is in the middle. I mean, in some sense, that's why it's 2, but I don't think anybody actually thinks about factorials like that. If that power up there is 30, then I'm definitely going to start thinking about factorials, because I definitely don't know the 30th row of Pascal's triangle. Good, right, okay, well, I'm having fun. The way this show normally works is that I give you a random question so that we've all done something that we didn't see coming, but then quite quickly we switch over to either revision or looking at some of those revision questions. If you don't know what I'm talking about, hello, welcome to the MAT Livestream. There's a worksheet which is scrolling up and down at the top there. I know it looks very slick, it looks like a kind of like split screen interface thing, but that is secretly just a PDF. And you can have the PDF as well if you like, it's free, and it's on that website. It also comes with a web version so that you can view it on your phone without having to download stuff. The web version is quite interesting to make, but let's not talk about that right now. It's a PDF before it's a web version. Never mind, let's not do it right now. It's not interesting to anyone except me. Right. Revision notes then, let's have a quick look at this PDF. So if you'd like a copy of these, you can get these if you want to read them at a sensible pace. The task here is to try and explain what sequences look like in general and to explain what it might mean to sum some of these things. I've tried to include 2 common ways that people do their sums, either starting from 0 or starting from 1, because different people tend to do different things. And when you've got a team of people writing questions for a test, you might find that some of them start from 0 and some of them start from 1. I know this back from when we used to write maths admissions test questions, that some question setters would start their sequences at 0, some would start at 1, so you would end up with different questions across different years or even within the same paper that were doing different things. I guess I'm just highlighting this as a thing to watch out for. Those 2 sort of sigmas, the big summation notation, different ways to do things. Hi Rex, good to see you in chat. Right, there are some rules that you need to know, some sorts of sequences that you need to be able to recognise. One of them is an arithmetic sequence, which is just above my head here. Let's scroll a little bit. So one is an arithmetic sequence where the terms have a common difference. You've met loads of these before because the counting numbers are an example of this, 1, 2, 3, 4. But with a larger constant jump or even a negative constant jump, you can make other sequences like the odd numbers or the numbers that are 3 more than a multiple of 6. Sort of examples of arithmetic sequences. They're fun. They don't have to be whole numbers. They might be. Both my examples there were whole numbers, but they don't have to. There is a formula for adding up the first n terms of an arithmetic sequence. I think I used to ask people to prove this formula works, but that stressed people out if I put it on the sheet. So I'll just do it out loud, which is less stressful. If you want to have something to think about, and you haven't already thought about it, that formula up there that says n over 2 brackets 2a plus n minus 1 times d, where's that come from? What's going on there? Yes. But you don't have to. I don't think you're going to be asked to prove it on TMUA. But it's multiple choice, so that would be quite a weird question. Still, thinking about stuff is probably good for you. So if you're playing along, pause, think, where are these terms? I have a mnemonic, which is first term plus last term, multiplied by the number of terms, divided by 2. And I know that some people in chat, you can let me know if you remember it like this. Some people have told me that they remember it as average term multiplied by the number of terms, which is pretty good shorthand for total, right? Average multiplied by number. Of course, you have to remember what you mean by average, and that the average, it works out if you just take the first and last to work out what the average term is. Relying heavily on the idea that the terms are equally spaced. I'm saying all of this because that rule, average term multiplied by number of terms, just doesn't work for other sorts of sequence. It's arithmetic sequences that it works for. You know that, I think. You know that your formula, it doesn't generally work on any sort of sequence. Anyway, right. In chat, Shen says, hi, some mods. And Anonymous says, since there are a limited number of TMUA questions, do I think that MAT papers are good practice? Yes. I've even recommended, have I done it this week? Or is it more a next week sort of thing? There are some points in the solutions document where the extension activities say, if you like this, go and look at this particular MAT question. I think none of them this week. But on the geometry sheet, I know that some of the extension activities are just go and look at these specific MAT questions if you like. And I've put a link to the MATS website on the homepage for this show, so that people can find more related questions. I'm a sort of big believer in just doing other questions, whether or not they're from the correct test, so long as they involve relevant mathematics and you find them tricky. Mathematicians test, which existed until last year, past papers are still there, people to try stuff. And Violet has put a direct link to the thing on screen. Thank you, Violet. That's pretty good. I should consider getting that ready before the show so I can paste it, or I could just let chat work it out. Helpful punch. Right, good. Okay. Right, I'm going to do geometric series, and then Anonymous has asked the fantastic question, which is, if you could add anything new to TMUA syllabus, what would you add? To which I have loads of answers, but that's probably just scary. So let's do geometric stuff instead. Geometric sequence has a constant ratio. So you've seen this when you sort of repeatedly multiply, possibly because you're doubling something every turn, or possibly because you're applying an interest rate lots of times, possibly because you're halving something repeatedly, or you're looking at a quarter of a quarter of a quarter of a quarter of a shape. And these turn up in geometry problems quite a lot. Let me show you my favourite, because one person asked, which is enough. Why geometric? We'll do some geometry next week. But in geometry, you have things like similar triangles, and you have other sorts of similar shapes as well. We'll see some similar sectors of circles next week out. That gives a kind of ratio between things. My favourite example is this problem, where you have a pair of lines and you have a sequence of circles that are tangent to each other and to both the lines. So this is not a straight line. There's some angle there, and there's, yeah, never mind, okay. But they're tangent to each other and to the lines. You can take a copy of that picture and scale everything down until the big circle is the size of the small circle. And if you do that, under the scaling, all the angles stay the same, and you get a new, smaller circle, which will be tangent, because you've made the large circle the size of the next one, and this one will have scaled down to some new circle down there. This means that there's a ratio to get from big circle to middle circle, and it's the same ratio to get down to the next circle down. So you get these kind of like similarity because you get this common ratio of the radius or the area or the circumference or anything like that. You can keep going. If you keep going, then you get this infinite chain of circles. Maybe I'll put a large one in as well, just to sort of illustrate. You could go the other way if you wanted. You could scale up. You get this infinite sequence of circles tangent to each other, disappearing into the corner. That's a geometric progression using geometry. So, question: if I stop this at some point, what proportion of the figure is coloured in? Well, that's some question about adding up all of the terms in that geometric series, adding up all of those areas, plus some really awful geometry bit for working out what's going on where I drew the line, but let's not worry about that. Okay, this is my absolute favourite sort of geometry thing, right? Ratio of circles in terms of the angles. Yeah. So there's something to do with the angle alpha, which controls all of this. Challenge, I suppose, if you want to get ahead with geometry, is to try and understand what's going on there in terms of what the scale factor would be given the number alpha. And then see if you can build it in Desmos or something. If you can build it in Desmos, then you've definitely understood it. Know Desmos? Everyone knows Desmos. So the website that lets you do graph sketching really quickly. Anyway. Right, okay. There is a rule for adding together the terms of a geometric sequence. If you're adding together n of them, the first n terms, you get a times 1 minus r to the n in brackets, divided by 1 minus r, and then provided that ratio r is between -1 and 1, you can add up infinitely many terms of the geometric progression, which sounds weird and doesn't get treated very well at A level, but we're just telling you this fact that if you add up all of them, what does that even mean? Well, infinitely much adding? Whatever. Maybe you learn that the sum as you add up lots of these gets closer and closer to a number. You can imagine these small circles in that geometry picture that I drew not really mattering. Yeah, so Louis asked about geometric mean as well, which is on the geometry worksheet. So I think I'll let you discover the link to geometric mean on the extension activity for the final question on the geometry sheet for next week, which is now public. Haha, right, okay. Right. Are Pollock's doing this work with exams? Of course. Yes, good luck to her. Pollock, student moderator. Oh, goodness me. And while I'm doing chat shoutouts, there's a request there for other than Matt, what other resources. I also like the STEP support program. I like Enrich and BMO and UKMT things. I just sort of like any sort of tricky maths problems you can find. It hardly matters where you get them. I've never done AEA, but I've heard about AEA, and other people have told me it's got tricky maths problems on. So I sort of endorse things like this as well, right? Which is, if it sounds like it's got tricky maths on it, then whoa, let's have a go at that. Okay, we've got the binomial theorem on the revision list here, and I added a bullet point at the end, which is not explicitly on the bullet points above for the specification, but I think we should all know it, which is what's a periodic sequence, or one that repeats, and that has an order or a period. So threw a bullet point in there. I'm trying to add bullet points that I think might be helpful, cover all bases as much as I can, but hey, whatever. Okay, we're going to try some revision questions. I'm trying to keep the pace up because if you already knew all of those facts, then, well, I'm having fun. But on the other hand, somebody probably didn't know all of those facts. And they've seen a very quick overview, and they know where to find a PDF, and they know roughly what's in the PDF. Next up, we're going to try some revision questions. The idea of these is it's a sort of litmus test. If you can do the question, it probably means that you have seen the material before, or it means that you've just understood the revision notes from reading them. If you can't, then it either means you haven't seen that topic, or the question is quite tricky. Some of them are quite tricky, sorry. I like making questions tricky. We're going to do a vote, because voting is good for us. The vote is a poll for all of the revision questions. I'm going to scroll them a little bit before I show you the poll. Have I done this correctly? I think I've done this correctly. Multiple options. You can select up to 17, which is all of them. And people can vote for which ones they want to do. Yeah, I think I've set that up right. Okay, it's a lot of clicking, isn't it? It takes time for people to do things. I've got to remember that. Right, okay. Roughly speaking, there are some questions at the top about sequences in general. I've tried to include like testers for convergence in here with some tricky looking sums that might or might not be geometric progression sums, asking whether that converges. Keyword, by the way, converge here. For the purposes of TMUA, in particular, if that's a test that's important to you, it's the test that Oxford's using for math submissions. Converge, I think, only gets used for geometric sequences, because I think you've learned about anything else converging to anything else. So those questions say converge, which doesn't mathematically imply anything, but does in exam awareness stuff The revision notes only say converge once. Anyway, never mind. Exam strategy, what are we talking about? Questions about arithmetic progression that say arithmetic progression, questions about even integers that don't say arithmetic progression, and then something about a pretty good sequence of numbers down here for 14. People want to do 14? 14 is winning, hooray! Good, 14's got a tricky sum in it, and 14 is maybe my favourite. Also 17 is going quite well. That's because I've worded 17 really badly, isn't it? Sorry about that. Yeah, probably I don't want you to actually calculate that number. I would accept it in the form of some sort of power. Maybe that's vague enough to be helpful or unhelpful. Right, okay. 14 is winning, then 17, then a bit of a gap, then 7. What's 7? Oh, convergence. Okay. People do want to learn about convergence. A bit of a gap with 7, and then sort of 16 maybe. Which I think 16 is binomial. I've listed the terms in the wrong order, right? So it's 3x minus 1. But luckily it's an even power, so you're allowed to flip that around to be 1 minus 3x to the power of 4. Aha! Even powers, they're like squares. So it's an even. Anyway, never mind. Good, okay. Anything in chat? Okay. Right. Shall I leave the poll going? I'm going to leave the poll going. I think in Slido people can tab between the two. We'll find out. Because it's time to go to the split screen and try and get question 14 on screen so that we can have a go at question 14, because that's on the vote. Okay. Question 14 is about a sequence of numbers that's defined in a really strange way. This happens sometimes on this sort of test, like maths admissions test or test of mathematics for university admissions, or whichever one is being used for university admissions near you. Just a sequence where each term is defined in terms of the previous terms in just some like almost arbitrary and maybe confusing way. Here it's defined in terms of a sum. So we're told that C0 is 1, great start, and we're asked to find C1. We're given this horrible formula. We're told for n greater than or equal to 0, the sum from I is 0 to n of Ci Cn minus I. That's what Cn plus 1 is. I forgot to write the left-hand side, so there it is, clumsily over there. Okay. When you see a fact like this, for n greater than or equal to 0, you always have the option of just trying some numbers. So this is scary perhaps, but it's infinitely many facts. But each of the individual facts is not that bad. So for example, we're being told that putting in n equals 3 or something, 3 up here, 3 down here is C4, and that's one of the ones I want. I want C4. I can even expand this a little bit further by thinking about what happens as I run across the different values of I. So the sum itself is like a for loop or something. It wants you to go through different values, starting with this one, inclusive, finishing with this one, inclusive, and adding some stuff together. So for example, this will be C0, C3 plus, so I've replaced I with 0 here and here, and plus because this whole thing is about adding, and then C1, C2, where I've replaced I equals 1, the next number in here and here. And to be honest, I'm now looking for a pattern because I'm bad at the kind of precision of thinking I equals 2 now. 2, 1, oh my goodness. I'm looking for a pattern, which is that as I increases, this suffix down here is going up. So the pattern that I want to write next, I want to write C2, the next number. And this one, 3, 2, is going down, where I suppose I'm putting words on what does it mean to have the pattern 3 minus I. It means something that starts at 3 and goes down if I starts at 0. You're welcome to just imagine each of the numbers I at 0 to 3 and do it very carefully, but I like to spot patterns. Okay. I have some horrible looking equation now, which my claim is that that's less scary than having the sum at the top. Of course, this is not helpful yet. It tells me C4 in terms of other stuff, but I can see that maybe by that point at the end of the question, I'll have all of the rest of those. I know C0 is 1. I can replace those, but I've tried to skip steps here, haven't I? And instead of putting in n equals 3, I need to do things like n equals 0. So let's do that over here. N equals 0 is interesting because this sum from I equals 0 to 0 just means I equals 0. So almost no adding to do. This is just C0, C. Oh, this here is a 0 because it's n. And then this 0 is a 0 because I is 0. Those are both C0, but sort of almost for different reasons. This one is Ci, I happens to be 0, and this one is Cn minus I. Both of those is, anyway, whatever. This is 1 times 1. 1 times 1 is 1. Welcome to the Oxford MAT Admissions Test live stream. Okay, that's not the one that people want help with, maybe. Or maybe it's just that weirdness of, when do you ever see a sum that says 0 on the top? That is weird. Let's try n equals 1, and I'm going to try and do this one sideways. So the sum is from I is 0 to 1. It's the number of terms that changes, and I suppose what the suffices are on the terms. So Ci, C1 minus I, which means C0, C1 plus C1, C0. The pattern is these ones go up till you get to the top number, and these ones are going down, which is 1 times 1 plus 1 times 1, which is 1 plus 1, which is 2. Okay, and that's C2. So I think you keep going. And the rule is kind of that you're taking the sequence so far. I love putting words on things. Sequence so far, and also sequence so far written backwards, like that, and sticking them together. So if I'm feeling brave, I might try it like that, which is that C3 is sequence so far but backwards, times plus plus, is 2 plus 1 plus 2 is 5. And then C4 is sequence so far but backwards. This is very dangerous. I don't really like this. Is it making you nervous? It's making me nervous. 14, I think. Check I haven't messed up. I don't think I've messed up. But for me, it's about finding those patterns, about finding this idea that 3 minus I, what does that even mean? Or n minus I, what's that doing? And what does this look like in general? Can I spot those patterns as we go through? How is C1 1? So C1 1 is this calculation up here. Oh, yeah, that is on screen. C1 is this sum. It's awkward. It's the case where n is 0. The fact in the question says for n greater than or equal to 0. I'm getting all the juice out of the lemon. I'm even using the case where n is equal to 0. Because that will tell me C0 plus 1 is 1. So it'll tell me C1. And that's the awkward sum where I'm summing from 0 to 0, but it's inclusive. So that term gets included. I've written it out in all its glory just here. But that is just 1 times 1. So it's weird. There's something slightly weirder, which isn't in this question, but I want to tell you about it, just in case, which is that, so this sum is just one term. You occasionally come across, probably not on a test like this, but maybe in real life, a sum which starts at 0 and like stops at -1, which doesn't mean anything. So this is considered to be 0. Where the stop condition is kind of before the start condition, which doesn't make any sense. I don't like that at all. People generally treat those as 0 if they turn up. It's occasionally helpful to just have that give 0 rather than an error message, but why am I talking like a computer scientist? Because all of that is maths as well. Right, good, yes. Somebody in chat has recognised these are the Catalan numbers. I have a whole textbook about the Catalan numbers. I love the Catalan numbers. The textbook is just 200 different problems. The answer is always the Catalan numbers, this sequence on the board. So it's a book where you know all of the answers before you start, but you have to do many questions involving weird definitions which end up giving you the same sequence. They've turned up on various places at various times. You definitely don't need to know anything about it. You can buy the book if you like, but it's not. Don't buy the book, right? That's not an advert. I'm just really proud of the ridiculous nature of my Catalan numbers book. Right. Good. C4 was 14. Oh, brilliant. Could you find an nth term? Yeah, you could. There is a formula for these directly. Maybe slightly disappointing. It's not even that weird. There's a formula for these that uses binomial coefficients, things that you've already seen on this worksheet. It's not very obvious. And demonstrating that it's the same thing is one of the questions in the Catalan numbers book. Anyway, I could talk about the Catalan numbers for hours. I should probably not do that. I should look at question 17 instead, which asks you for the sum of the coefficients. That's a bit of a cheeky question, right? Cheeky question. Let's try it out. So there are two ways of doing this. Well, there's two ways of doing the first bit. I do like a cheeky question, but so first method is just the sort of honest method where you do the question properly. I'm going to write it out because I'm trying to model good behavior, right? 2 to the power of 1. Very tempting to try and do that in my head, but then if I do it in my head, you can't see what I'm doing. Also, I would get it wrong. So this is x cubed plus, what is that? Well, I regret writing my x's like this. Fixing it. There we go. Borderline. Hooray. Okay, so the sum of the coefficients is, there's a coefficient of 1 here, and 6 here, and 12 here, and 8, which is 27. And then the question asks us for x plus 2 to the power of 300, which I definitely do not want to multiply out. I definitely don't want to write that out. There are 301 terms, for example, which is too many. And adding them would be a real pain. Maybe you know facts about binomial coefficients. Not really expecting you to know facts about binomial coefficients. There's all those factorials, right? Although they're quite hard to work with, and there are 301 of them, so tricky. There is a better way to find the sum of the coefficients. What I would like to point out, in case you haven't seen it yet, is I would like you to stare at the relationship between this polynomial and the sum of its coefficients. If we can find any nice relationship between that polynomial and the sum of its coefficients, maybe that's not a concept we've met before, the sum of its coefficients, what's going on there. If you can find a nice relationship between those, then, well, it'll save me from writing it out, right? If you have some sort of trick. This is me trying to get chat to tell me what to do. I did turn off the poll because I wanted to get chat on screen. I'm impressed with 3 and 9. Sure, maybe it's 26. We're doing quite good for time. Okay, chat. Someone is. Someone's had a go. Yeah. Does the constant term count as a coefficient? Says chat. Yeah, I think so. I think I've sometimes called that the constant coefficient. If you like, it's the coefficient of x to the power of 0. And that's the coefficient of x to the power of 1. So for me, they're all coefficients. That's what a polynomial is. Well, it's also got the x in it as well, hasn't it? But yeah. Yes. Oh, and good spot as well. Matthew in chat has pointed out that 27, even if you don't spot the kind of purple link between these things, it's sort of suspicious that this is 3 cubed. It's a nice number. There's a lot of 3's going on in this question. What's happened here? And in chat, they're up to there you go. Good stuff, chat. So one way to do this step quickly is to go just set x equals 1 to get the sum. Oh, it's underneath chat of the coefficients. Once you've seen this, any future question you meet that asks you for the sum of the coefficients of a polynomial will briefly look scary because, wow, that polynomial could have loads of coefficients, but will always, whenever you meet it from now on, just fall over if you remember that the sum of the coefficients just comes from setting x equals 1. Of course it does, right? Because then all the powers of x will turn into factors of 1, and you'll just be left with all the coefficients. So I don't mind if you spotted it now or not, but next time we're all going to spot it. One of those things, isn't it, right? Partly maths is experience. We're building up a bank of these like, what a weird trick. It's not going to catch me out next time. And one of the things I've done is, maybe compared to you, an extra 10, 15 years of joining up and finding extra tricks. Right, okay, yes. Yeah, so x plus 1 to the power of n will give you 2 to the power of n, says Alan in chat. Yeah, that's extra coefficients. Yeah, so I suppose the other idea is, if you're just going to set x equals 1, then you might as well do that over here. If these things are truly equal for all values of x, that includes x equals 1. So you could just set x equals 1 over here. So the sum of the coefficients of this, including the constant coefficient and including the 1 in front of x to the power of 300, is just 1 plus 2 to the power of 300. Because it's a polynomial, and whenever I want the sum of the coefficients of a polynomial, just plug in x equals 1. Hooray, right, okay. That was somebody's first time of seeing that trick. I don't quite know who, because I sort of did it the way round, where people posted in chat if they'd worked it out or if they'd seen it before. But I think it was someone's first time seeing that trick. So, haha, there you go. I don't know if it's useful. I don't know if it's going to come up ever again in your life. I'm saying next time, but who knows? Inspired by this, you might think about what other tricks can I invent, right? What happens if I try x equals 0? What does that tell me? What's the question where the answer is naha? You just plug in x equals 0. Right. What does that do? If that one's not interesting enough for you, what's the question where the answer is just plug in x equals -1? I think I've seen a question where that was the right answer. So just plug in x equals -1, and then goodness knows what you were trying to calculate. That's what we can work out, I think. Right, okay. I love the fact you can get information out of the polynomial without actually writing out all the terms. It's always an option to you to write out all of the terms of the polynomial if you have some explicit definition like this where you could go and use the binomial theorem. But no one's making you use the binomial theorem. You don't have to if you don't want to. Right, okay. Yeah, okay. Y-intercept, constant term, people are good at x equals 0. X equals 0 is going to remove most of these terms and just leave us with this last one. It's 2 cubed, just 8. I don't even have to think about binomial expansion. Right, good. Okay, good stuff. Thank you, chat, for joining in. I will try and remember to get people to join in. There was a request in chat, so I've got a few coming up. 7 got some votes. 7 on screen there is a geometric progression. What's the sum of the terms of a geometric progression? You can do this in several ways, actually. So geometric series. Put this on. For me, the sequence, like the geometric sequence behind the scenes in the question, is 2 minus x squared over 2 minus x cubed over 4. And so that the ratio is minus x over 2. So I'm interested in whether that's between -1 and 1, and now there's some inequality thing. So is that? I'm not even going to write it out. Is that between -1 and 1 is the question. Or I've seen other people do this in other ways. So something like 2 minus x for the first time, first term, x squared over 2 minus x to the 3 over 4. That's a geometric sequence as well, with ratio, oh my goodness, I think x squared over 4, I think. Then maybe you spotted that as like the first term is 2 minus x. Who says it can't be, right? And then the second term is x squared over 2 minus x cubed over 4. You're going to be taking pairs of my sequence and joining them up. That's also a geometric progression. Something to think about, perhaps, is that whenever you have a geometric sequence, if you add up pairs of terms, so the first and second, and then the third and fourth, then the fifth and sixth, then the seventh and eighth, if you add those pairs to make a new sequence, that's also a geometric progression. And if you wanted to add infinitely many of these terms, you're going to get all of them either way, so you better get the same answer. In fact, asking the question, is that between -1 and 1, is the same as asking the question of whether this is between -1 and 1. I've written x to the 4, but I think I said x squared out loud, which is the correct number. How are we doing in chat? Are they calling me out in chat? Yes. Aha! People are telling me about -1. Thank you, Riemann hypothesis in chat. He spotted the typo. I don't promise 0 typos. And there's a suggestion in chat for what happens if you put in x equals -1. It's quite a long chat message. I'm not going to read it all out, but it is. I think it's true, and believe it or not, for the person who wrote that, believe it or not, it is a thing that I once needed. So that was the answer. Plug in x equals -1. Right, good. I'm not going to put it on the screen because I want to leave some mystery. People can look in chat if they want to see what you've typed. Anyway, right. There are requests for 3 and 9. 3 and 9. So 3 is another geometric progression. Just put this screen up here. Each thing is 1/3 of the previous term. So there's a formula for this. If you want to add up 10 of the terms or infinitely many of the terms, that's allowed because 1/3, that ratio is between -1 and 1. There are some formulas for them. I will let you try this because I want to see if you can find the formulas. If you've requested question 3, I want to see if you can find the formulas from the revision notes. And if you want to check your answer, you can do that quite easily in the solutions document. Have I shown you the solutions document? I can put it on the screen. I'm not going to do it now. I've worked out how to get it on the screen though, if need be. I can't remember the number. I don't know. I've asked for A1000 as well. I was not expecting anybody to actually work out 1/3 to the power of 1000. In case that's not clear, I didn't work out 3 to the 300 just now. Maybe the question should say that. And then there was a request for 9 as well, which is about adding together some of the terms of an arithmetic progression and then looking at the next k terms of an arithmetic progression, which is one of the TMUA questions. I think we probably will cover this one way or the other. Okay, I'm going to have a quick look at the poll. I'm sort of switching it back on, but how do I do this? Do I bin things? Done editing. No, I don't edit. Oh, okay. I have to scroll down the poll. Oh dear. What a tricky poll. So 14, 17, 16, 17, it brings up this control thing as well. 10 got some votes. We could talk about 10. I only had a very quick look at 3 and 9, and I'm sorry for that. 9 feels like spoilers for one of the questions that's coming up, so I wanted to keep thinking about it. And then after the break, we might see a longer version of that question. 10 and 5? Solve everything now, about 20% and down. There's a sort of block of 14% down there, which I think is like a bunch of people waiting for lots of things. We could do 10. Let's do 5 and 10. Okay, that poll moment was mostly me checking the results. Thank you for voting in the few seconds that it was up as well. Good. 5 is a mess. Let's do 5. I don't know why I thought this would be fun. But occasionally you have a guess for what the formula is of it for a sequence. This one is a bit awkward. To stop you from using just formulas from the revision notes for this, I've picked a sort of sequence that's not on the TMUA specification, which is a quadratic sequence. Yes. Pretty sure that's not in the spec. Okay. So, for example, this style of sequence, it's supposed to be when n equals 0, you get this first term. I know it's awkward that I've done it so that the last thing is the first term, but whatever. When n equals 0, you get this first term, and then you don't just have a constant difference, the difference between terms is also changing over time. There's a sort of quadratic equation for what the terms are of the sequence. Awkward. Anyway, the question is to think about how, if you're given values for A0, A1, and A2, to work out what the relationship is. So I suppose what I'm looking for is something like horrible algebra to convert our knowledge about what A1, A0, A1, and A2 are into facts about capital A, B, C. So for example, this is what n equals 0 means. Hey, look, here's another opportunity where I'm replacing all of the n's. This is true for all n. So I'm replacing it with specific numbers, 0, 1, and 2. And I'm writing out things like 0 squared, not to be patronizing, not to pretend that 0 squared is effort for you, but to be really clear about where I'm replacing n. Sorry, I know it looks super weird to have like 1 squared written out there, and it is a bit of a recurring joke that I ask you to multiply 1 by 1, but here we are. Okay, let's simplify. So that's C, that's A plus B plus C, that's 4A plus 2B plus C. And then I suppose what it looks like is I've got some equations, and what does it say? Find capital A, B, and C in terms of A0, A1, A2. So I have A0, A1, A2 in terms of big A, B, C, and I want it the other way around. So it's sort of like solving equations, isn't it? So that one turns around nice and simply, but then the others are going to be a pain. So A plus B plus this C over here, I'm already going to write A0. And this one, getting quite low. Okay. So there's something going on here where I've got two unknowns, A and B. They've got some coefficients, 1, 1, 4, 2. And I would like that in terms of these things. Which is fair enough. That looks like simultaneous equations. I'm probably going to do stuff like doubling this first equation, taking the difference, and that'll eliminate b's. Could be a bunch of terms. Yes. Shall I actually do that live? It's probably good for me, isn't it? You voted for this. It's my fallback. You voted for this, right? And we'll do an hour of TMUA questions. Okay. So I'm going to move the A0s onto the right-hand side, just so that I've got real separation between the things that I want and the things that I've got. Okay, I know the handwriting's bad, but I kind of remember where things came from as well, so that's a bit better. Okay, what did I say I would do? Double the first equation to get 2b. And then do the difference, which will leave me with 2a on the left-hand side. I am working down because, let's just go full screen. 2a, I'm working downwards because I like to align the equal signs if I can, so it keeps things tidy. So it's a2 minus a0 minus 2, a1 minus a0. Shall I tidy that up? I probably should. It's not that bad, right? It's a2 minus 2 lots of a1 plus an a0, because this minus 2 distributes to become plus 2, adds on to minus 1. Goodness me. Hey, that's not too bad actually. That's like the, there's a name for that, whatever. Okay, so a is a2 minus 2a1 plus a0 divided by 2. And then b is, let's see if I can do this in 1. Well, I can do something in 1. So looking back up here to find the simplest equation that involves b, ideally on its own, there's one up here. Back down, I've got to write a1 minus a0 minus whatever you have for a, and that's a lot of stuff. Okay, I could stop there, but I might try and tidy it up a little bit. I'm going to put brackets just for safety. What is that? Minus distributed giving a +1, so 2a1. Minus, is this correct? Yeah. Yuck. Got that right? Maybe. Check solutions. I've lost all confidence in my ability to solve simultaneous equations. Oh, yeah. Oh, yeah, crikey, okay. I remember that coming out nicer in, in the past. What's going on here? Hard question for chat. Oh, chat's pasted some stuff. Half a0, half a2 minus a1. Yeah, that's quite nice, isn't it? 2a1 minus 3 over 2a0. Yeah. Okay, I've got the same thing as Sadler's in chat, so I'm happy, I think. Ugh. Yuck. Is there something going on here? This thing has got something going on, which is that you could rewrite this if you wanted to. It's kind of up here, but let's rewrite it like this. It's a2 minus a1 minus a1 minus a0 divided by 2. That's related to something called the second difference, where you work out the differences for your sequence, and then you work out the second difference, the difference of the differences. And sometimes people learn about these sequences, possibly at GCSE, I don't know. Tell me if you learned about these at GCSE or equivalent. Sometimes people learn that you can, if you have a sequence like this, the thing that you do is you work out the differences, and then you work out the second differences, and you divide this number by 2, and that gives you the leading coefficient, capital A, which is also what the formula tells us down here. We've worked out a formula for a GCSE fact to work out why it works, depending on whether you agree that this is GCSE or not. And then there's some formula for B, which I don't think anyone actually learns, but in theory you can work out everything just from the first 3 numbers and the information that it is one of these sorts of sequences. Okay, that's 5, and that's taken a big chunk of time because I, for reasons known only to myself, made myself do all of the algebra. Okay, one more. I think 10 was doing all right, wasn't it? One more. This tends to be a topic that people, if you're in year 12 going into year 13, then depending on how things are sequenced in your school or sixth form, if you're doing A-levels, oh gosh, so many qualifiers, right? If you're doing A-levels, if you're in sixth form, if you're in between year 12 and year 13, then, deep breath, this might be something that you've not learned yet, but will learn quite soon. So possibly, unlike the algebra from last week and the geometry next week, possibly some of this is new material, but it won't be new for long. In some sense, it's not new anymore, but also from a school point of view. 10 flips the script and gives you the sum of the first n terms, from which we are supposed to work out what the nth term is. My advice for this is to investigate that fact. So we're given sum of the first n terms is 3n squared plus 5n. And my advice is to look very closely at the fact. Give it a hard stare and imagine, oh yeah, does that include n equals 1? I think it does include n equals 1, right? We've seen earlier that putting in x equals 1 was a kind of good shortcut. Sometimes plugging in small numbers is a good idea. Sum of the first 1 terms is 3 times 1 squared plus 5 times 1 is 8. That's interesting because the sum of the first 1 terms is probably just the first term. What am I going to try next? It's kind of obvious what I'm going to try next, isn't it? I would like to just look at the sum of the first. 2 terms TE. There is a more honest way to do this, right? I feel like I'm sort of trying to hack this question apart by just looking at small values. Ooh, what's the sum of the first 1 terms, TE? The more honest way of doing this would perhaps be, honest, is that a thing? I don't really mean honest. Would perhaps be to write out some sort of formula like, well, in general, it's half times n times 2a plus n minus 1d, and then try to like compare coefficients. The sort of comparing coefficients is a bit like thinking about all values of n at once. But on the other hand, we've seen that comparing the coefficients is quite a lot like checking specific values of n. We've seen that comparing all of the coefficients is sort of just the same thing as checking n equals 1. Anyway, 12 and 10 is 22. So now I'm really interested because the sum of the first 1 terms was 8, and the sum of the first 2 terms is 22. It's gone up by 14. So I think I can work out the first term and the second term. And then I'll know everything because of geometric sequences. Ooh. What's chat up to? Right, we're coming up to 6 o'clock. So I'm going to have a quick look at chat, keep up with what chat's doing. Extreme combinatorics wants to know, in general, is it always possible to work out the nth term of a polynomial sequence given the first k terms if the highest power is k? And why? Answer, yes. That's the right intuition. So possibly out by 1 or something. Over here, I have a polynomial of degree 2. It's a quadratic sequence, and I need to be told 3 things. But then I can solve the equations to work out the coefficients. Broadly speaking, that pattern keeps going. So if you know that it's a cubic sequence, which has an n cubed term in it as well, then you need 4 bits of information. You could use the first 4 terms. I am skipping some details as to why that always works, but I would encourage you to think about simultaneous equations and maybe try and generalize these ideas about differences to see if you can work out how things fit together. Good. I like the questions. Right. There is also a general theory for this. Loads of these things have been around for so many, like, hundreds of years that there is a general theory, and I feel like I have to mention it, but I'm not really suggesting that people go and, like, learn about polynomial interpolation, because that doesn't sound very fun. Right. Or, like, a great use of your time. You have a choice, right, between solving problems and applying the maths that you've seen and thinking about connections between things you've already met versus trying to learn new stuff and sort of go out and find out about extremal combinatorics or category theory or partial differential equations to just glance over the Slido chat. I sort of think that building the skill set is also important. That maybe you want to look ahead to see future maths that you might learn at university. There's loads of it, so you're not going to run out. On the other hand, also working with a limited toolkit, there's a sort of fun in that as well. Right, so what I've done is I've labelled this helpfully for myself. It's going to be a very quick break here at 6 o'clock. If you've been staring at a screen for the last hour, please remember to look away from the screen and remember that you're human. Humans occasionally look away from screens and blink. I'm going to drink some water as well. What I've done is I've labelled my notes, but I've labelled them wrong. So this is an improvement on last week, where the notes were not labelled at all. But there's a room for improvement. That I can dream that maybe next week I will label my notes correctly. 2 plus 6n. I like it. Depends if you count the first term as n equals 0 or n equals 1. There. What's a CP1 series? I don't know that. I'm going to Google it. Is it a 1 or an L? Scorpia? I don't know. Some sort of series. Anyway. Like an arithmetic sequence? Are they telling me to just use the formula that I have on the screen? I don't know. Okay, Anonymous, I don't know what you mean. I'm sorry. Right, okay, I'm ready for some TMUA questions, I think. It is just after 6. So Thursday evening. It's about live stream time. Here we are. Let's put them full screen, because that seems fun. I'm going to hide chat briefly so we can have a look at what we've got. Here are the 6 TMUA questions that I've picked for this week. There's this fact about the terms in a geometric progression. We can have a look at this one if you want to think about equating terms between geometric and arithmetic progressions. We're also given a fact about sum to infinity, so if that's a new fact for you, then you might like to practice this question to practice what does it mean for the sum to infinity of the geometric progression to be 12 out of all of the things it might be. There is a question that you might like to look at. This is from paper 2. It has some necessary and sufficient language going on. There's quite a lot of reading, but to actually do it, I want to reassure you that we mostly just do maths. We would like to understand the sequences in the question in order to work out whether those things are true or not. I'm going to scroll really quickly past the hints. If you get the worksheet, which is on the website, you can read a page of hints that I've written for those 2 questions. And maybe we'll try this question, which asks us to think about a sequence where we're adding together values of this trigonometric function. We've got sine. So this question also says necessary and sufficient. This time we're really not going to panic. That just means that we have to do the question properly. It means for which values of n is this fact true. Not just some of them, and don't include any wrong answers. That's what necessary and sufficient means in this context. Or maybe let's try some integration. We've got an integration question. This one involves a sequence, sort of. It involves a sum. There's some notation in here that I thought this goes on the sequences and series sheet. It's thematically about building an integral out of lots of other integrals. So it's kind of a sum of a sum, really. I don't know. We found those tricky a moment ago with the Catalan numbers. If you want to try that, give it a back integral. Scrolling past the hints about how integration works. We've got a past question here about, this is the one that I think people might want to do because it links together sums from different parts of a arithmetic progression. No, it's geometric. What am I talking about? Earlier I told someone a question was coming up later and it's really not. Oh well, here we are. Geometric progression, summing up maybe different parts of that sequence to get the same answer sometimes. And further down, I've also included this question. It's also from paper 2. It's got this word necessarily in bold. And we can talk about what it means to be selecting terms such that a fact might or might not be true, if you like. Yeah, so in chat, but we're going to have a vote for this as well. I think I've set this up so that the questions are in the same order in the vote. I don't really know what happens when people start voting. Possibly it messes up the order, but at least right now they're in the order that they are on the thing. There's a request in chat, which was very polite, to look at the second one, so I'm going to put that on the screen underneath the voting while we're voting, just for a moment. And just in case it doesn't win the vote, I see this person in chat, and I'm going to say, second condition, for t to have a property p, it is necessary that d is even. Framework for this question, which I'm hiding slightly, is that fact might be true or false. The question's been carefully written to not give away whether it's true or false, which I'm wincing a bit because this affects professional mathematicians, right? You have a fact and you would like to know whether it's true or false, and the universe is not really giving you hints. The universe has just contains all the maths. You end up spending some of your time, usually, trying to prove that it's true, and some of your time trying to prove that it's false. Even though, at the end of the day, one of those won't have got anywhere, because it is not both true and false. So when I see a statement like, for t to have property p, it is necessary that d is even, part of my brain thinks, maybe d has to be even. What can I do if d is even? Is it necessary that d is even? And part of my brain, maybe the more mischievous part of my brain, thinks, no, I bet that's false. I bet that's wrong. How do we prove that wrong? Bit of mischievousness. Noun for mischievous? Anyway, a bit of mischief. There's a noun. A bit of mischief, maybe. If it's not necessary for d to be even, that would mean you can get away with d being odd. So if I can't prove this fact, then I might try and find an example with odd d. Of course, I've got no idea which values of d work unless I engage with the rest of the question. So try and find some condition involving d that actually goes, what even is property p, right? You have to actually engage with the things in the question too. So actually, if we do this question, we're going to try and work out what property p actually means, and then think, can we cheekily find a value of d that's odd and makes this work? Because if we can, then that knocks out statement 2 entirely. It just becomes rubbish. Statement 2 says it's necessary for d to be even. If we can find a single sequence with odd d that works, then it's gone. If we can't do that, then we'll go back to trying to prove it. They're alternating between the two. Not too quickly, not oscillating backwards and forwards too much between the two ways of doing things. Prove it, disprove it. But if we get stuck switching gears into reverse gear, I guess, for the analogy. Anyway, never mind. Right, what do people actually want to do? Is it this? This is in second place. This is in second place. I'm going to circle. But the poll is currently keen on 21,113. That's a bad system, isn't it? Because I have now got to find out what that is. Oh, the integration one. Okay, let's see what that can be. There's the vote for the record. And it seems a little bit volatile because that is also oscillating around. So I'm going to let that go for a little bit longer. Have I missed anything in chat? People looking at the extension about changing factors. If we can. I think to talk about the extension, I have now set it up so I can get the extension question on the screen. In order to talk about it, we have to also do the question. I will see. No, maybe that's not true. Maybe I can talk about whatever I want to. Right. Okay. The vote wobbled around a little bit and has now reassigned itself to be the sequence, the question that we were just looking at. I feel like I've put a hand on the scales. I'm not sorry. Right, okay, so 14 is now winning. Kept going. I'll just let that roll a little bit just to see, and then we'll do second, we'll do integration. And then maybe it goes back to dealer's choice after the first two. Right, okay. I think that's what we're up to. Let's hide this. Let's go split screen. Oh. Play an animation, why not? Actually, the stream's having fun as well. It is this one. And I immediately regret the split screen because look, how are we going to see that? Is it going to play it again? No, it's not going to play it again. Right. Oh dear. That's flustered me way more than it should. What's my software doing? I can't quite get the options on screen, but they're not exciting, and we're not there yet. Here's the question. Arithmetic sequence T has first term A and common difference D. That's what I like to see. Where they are, let's remember this, non-zero integers. So we're only dealing with whole numbers. They might be positive or negative, but they are not zero. Okay, property P is as follows. For some positive integer m, the sum of the first m terms of the sequence is equal to the sum of the first 2m terms of the sequence, which sounds mad to me, but here's an example where it happens. A is 11 and D is -2. I wish it had been D is -3 for the free example that they give us, right? If the free example had D being equal to -3, then it would already be a counterexample. Haha, that would disprove things. But no, sadly, it's got even. D is -2. Anyway, are people aware that negative numbers can be even? Yeah, everyone knows this, right? 0 is even, -2 is even, 12 is even, -14 is even. I hope that's not controversial. Tell me in chat if that's a new concept for you or controversial. But when I say -2 is even, I am hoping it's not controversial. Oh gosh. Where are we at? Okay, never mind, okay. Yes, I realised they're going to talk about negative numbers and they're going to say odd and even. Well, we've got to be on that. Anyway, here's an example. They're adding the first 4 terms and they're adding the first 8 terms. And something's happened, which causes both of those to be the same number, 32 in both cases. So, I would like to work out some maths for whether that happens or not. Which means, I think, getting to grips with this sum of the first m terms and sum of the first 2m terms. Luckily, it's an arithmetic progression, and I have facts about that. So I'm going to scroll so that property P is right at the top of the screen, and maybe the example, and I'm going to go split screen so I can write stuff. I'm going to talk out loud to try and make the software behave as it does stuff. Okay, so first m terms sum to, now, so I need one of my formulas, don't I? 1/2 of the number of terms times the first term plus the last term of 2a plus. I've done this in such a clumsy way. I think I've been thrown by the fact it's m rather than n, and that's made me think that I'm going to mess this up. No, I think I'm good so far. Okay, so then the first 2m terms, and now there's a real danger that I mess things up because of this 2m, and I can see 1/2 and extra factors of 2. So the chance that I get all of these right first time is pretty small. But the chance that I get it wrong both the first time and the second time is pretty small. Probability question down the side for the probability that I make the same mistake twice. Let's find out. So I've tried to replace n in the original equation with first m and then 2m here and here. I think means I've got the right thing. I'm also glancing over there, which is cheating, I suppose, but here we are. Okay. I want these to be equal. They don't really look equal, do they? I'm going to put question mark, exclamation mark on screen as well, just to remind myself that that's weird. So if I set these equal to each other, there's a factor of 1/2 in both. They've got that in common. There's a factor of m here, and I think m is non-zero. Look at the question. Yep, m is explicitly called out as a positive integer m. So I'm going to get rid of that as well. So that means 2a plus m minus 1d should be equal to twice, I haven't forgotten about that 2 there, twice 2a plus 2m minus 1d. And this is nothing to do with statements 1 and 2, which are somewhere underneath the whiteboard right now, but just try to get comfortable with what on earth this says. So I have 4a on the right, take away 2a. This is where I drop terms, isn't it? So I think if I'll move my a's over here, because I've got 4 a's over here and only 2 a's over here, and I've got 4m minus 2. Oh, this is a disaster waiting to happen, isn't it? Let's move the d's on the right hand side as well. So 4md, take away one of these md's, is 3md, and minus 2d plus one of them is minus 1d over here. Okay, so property P, let's rewrite it. It just says for some integer m that's positive, and then instead of all this text about the sum of the first m terms is equal to the sum of the first 2m terms of the sequence, I'm just going to write we have, and then copy this up, 2a plus 3m minus 1d equals 0. Okay, so I'm not going to park all of that stuff about calculating that. That's my version of property P. This is what I mean about engaging the question and trying to understand the things in here. Yes, EJ has got a different way of thinking about this, which I'm going to put on screen. EJ says that they've noticed in the example, perhaps, you can see this happen, which I think is right next door, isn't it? Anyway, yeah, it's toggled. It sort of straddles 0. I can have both. So you've got that 3, 1, minus 1, minus 3, which tells you, what does it tell you? You've got some terms doing cancellation between each other, so that adding on these extra m terms gives you nothing. A different way to think about this thing, I've set two sums equal to each other, but if you have an arithmetic sequence, then taking the terms after the first m, so forget about the first m terms, they're gone, The rest of the stuff that you've got is still an arithmetic progression because it's got a different first term now, but it's still got that common difference. I like to think of other ways that you can take subsets of the terms of an arithmetic progression and still have an arithmetic progression, if you like. Okay. This is where I start to get all the pages mixed up, isn't it? Oh, well, never mind. Okay. Chaos. What can I see? So one of the questions there, let's scroll down to the questions. I think whatever way you have of thinking about it, you get down to this expression for property P. Because this is necessary and sufficient, and all the steps I've done are if and only if. So whatever you've done, if it's also necessary and sufficient, if and only if, then not losing any cases, then you should probably get down to the same equation at the bottom. The same rule about which sequences, in terms of A and D, which values could possibly satisfy property P. Okay, what do I notice about this? Well, let's look at the two statements. Look at these two statements. So is it sufficient that AD is negative? Gosh. Were I told that? I was told, okay. Is it enough? The way of saying sufficient. Is it enough that A and D have different signs, that AD is negative? I like to try and rephrase things, right? We saw an example where A and D had different signs because A was 11 and D was -2. Is that enough? Well, probably not, because they've got to do this. They've got to do this equation. So it's sort of saying, can you simplify this down to just saying AD negative? And I cannot imagine a sequence of steps fully reversible which says actually to satisfy this you just need to have AD negative. That doesn't mean it's true or false, right? But struggling to see how I would prove that from here. Maybe I could rearrange this for M if I wanted to. But it just seems tricky because this has to be an integer M, which seems quite restrictive. And if I pick some random values for A and D, let's see what happens for, I don't know, so I'm going to pick these to be negative when you multiply them. So sort of see what happens for A equals 1, D equals -1. Well, in that case, there is some value of M that works, right? Because 2 plus 3m minus 1 times -1 is satisfied for m equals, oh gosh, 1. The first term is the same as the sum of the first two terms. Okay, but I can change this, right? There's a step in there where I divided something by 3, and I can't see any reason why it would be a multiple of 3. So I could sort of change numbers. Feel secure finding an example where AD is not less than 0, which still satisfies the equation. That's the wrong way around, I think. So a sufficient condition means that it's enough. Is it enough just to have AD negative? There might separately be cases, even if statement 1 is true, there might separately be some cases where AD is positive. It's not ruling those out. It's not saying anything about those. I think I'm supposed to do a real world example now of sort of sufficient and necessary. To get from Oxford to London, it's sufficient to get a train ticket. That'll do you. That's enough. I'm not saying it's the only way to get to London, but it's sufficient to get a train ticket. The existence of the bus doesn't sort of disprove my statement. It's kind of enough. It's sufficient. If you want to just get a train ticket, you can do that. There might be other ways of doing it, but the train ticket's enough. In order to disprove that, you need to actually tell me about trains. Tell me that no, they're not running. There's no trains. Let's look at the other statement as well. We have this thing about. So I think it's not true. I haven't found an example yet Yeah. Ah, I see in chat what's happening. Right, I wasn't following this, but there's some chit chat going backwards and forwards. Everyone's being nice and polite. That's good. Matty G has generalized this idea that it's symmetrical about 0 at some point. The idea that you see something like 1 followed by -1, which means that you have a jump from maybe not 1 and -1, but you have a jump from like 3 and -3. That's not necessarily the case because the sequence might include 0, which is sort of fine because 0 doesn't change the sum, but it changes how many steps you're doing. In fact, I've just realized this is an example. Property P holds. Didn't I want this earlier? So kind of to disprove statements in the first case for statement 1, if I'm trying to disprove things, breaking stuff feels more fun sometimes. If my job is to disprove things, then for statement 1, I need to find something that doesn't have property P, and for statement 2 to disprove that, I need to find something that does have property P. And hey, I've just noticed this is an odd value of D. Statement 2 reads that it would be necessary for D to be even, but no. This includes the term 0 in the sequence, and it's a small value of m. It says the first term is the same as the sum of the first 2 terms, but it's there. You can do other ones. Yeah. A term has to be 0, but that doesn't tell you very much. It tells you that D is a factor of A, but right? Yeah. If D is odd, then D is a factor of A, but that's not particularly. That's not related to statements 1 or 2, as far as I can tell. Okay, so this weirdly, I was trying to. What was I trying to do? I was trying to disprove statement 1, and I think I've accidentally disproved statement 2. So I still want to try other values, like A is 5 and D is -1. Feels like that's not going to do it, is it? Maybe I should stop setting D to be -1. -1 is kind of interesting because then I can just. Let's try this first. Setting D to be -1 is kind of interesting because I get this statement 2 plus 3m minus 1 becomes 2a equals 3m minus 1. So m is off the bottom of the screen. M is 2a plus 1 over 3. That might not be an integer. For example, it was when a is 1, the first thing I tried, but if I put a equals 2 in there, then I think it will fail, because m will be 5/3. It's the only number that works. So I think this goes 2, 1, 0, -1, -2, and although this sequence includes 0, it doesn't include it at the right place. So it has some sum of terms that gets repeated, but not the first m terms and the first 2m terms. That's not the same as 3. It doesn't do it because the kind of point where you would want to put m is 5/3, which is not a whole number. So I've been messing around a little bit, but I think I've managed to convince myself that both of these statements, 1 and 2, are both rubbish. I mean, you don't need to have D an even number. That's not necessary. You can satisfy property P with a rubbish sequence like this: 1, 0, -1, and there you go, first term and first 2 terms. There's probably better examples, larger values of A and D, but I don't need to find another one. One counter example is enough. And for the second statement where they say it's necessary that, for the first statement where they say it's sufficient that AD is negative, I think that's rubbish as well. I've got examples where it doesn't happen, even though AD is negative. Actually, I've just got one example, but again, that's enough. So I think both statements are rubbish. Right, sorry, excuse me. Good, okay, how's chat doing? Oh, chat's got loads of messages, whoops. Yeah, not necessary. We can construct such a sequence. Sorry, chat's going to go really fast up there. There we go. Ah, right, okay, chat was trying to help me. Sorry, there was a lag on chat. Not necessary. We may construct any sequence by having a 4, 5, and 6 be minus x, 0, and x, and then filling in a 1, 2, and 3. Yeah. That gives you some sequences, not the one in the question, so it's not all of them, but that would be sufficient. That would be enough. I've decided I like the word enough more than I like the word sufficient, and that my tip might be to translate like that. And instead of necessary, I might say needed. Yes, chat only updates when I do a thing. There's a moderation panel, which occasionally we forget about. Right. There is a bit of lag. Good, okay. A bit of an anticlimax, because I think I did the parts of the question in the wrong order, but maybe that's a good demonstration that sometimes you're messing around with the examples and you don't know what order you're going to find your examples in. So somewhere around here, we've got a proof that statement 2 is wrong, false, because we have an example with the odd, and somewhere down here we have an example that statement 1 is also false. Weird. The extension question for this is one of the ones where I imagine using this as an interview question. I'm trying this out for some of them. In the solutions document, I've got a kind of extension where we think about sort of roughly what proportion of sequences have property P. So we set D to be the number -5 instead, and choose A between 1 and 1,000 at random. What's the probability that it does this? It feels kind of unlikely to me, and I would like to try and put a number on that. So start off with a fixed value of D, varying A, but then ultimately maybe the interview goes to explore changing A and D. So you've got some grid of possibilities for A and D both varying. What proportion of those have something like that? I'm not doing it on every question, but just some of them. I feel like I can sort of see where I would go if I were using that as the start of an interview question. I'm trying to show people that interview questions don't just do a question and then run out of ideas. I'd like to try and have a discussion in a maths interview. Right. Good. Okay. One more. There was a vote for, so I'm not certain I did a great job, but I sort of found my counterexamples. They weren't the ones that I was planning to do, but never mind. Maybe nobody knows what I was planning. I should not let that faze me. I think there were votes for the integral question, which, see how we do at that one, just further down. Let's find the integral question. And maybe we'll sort of go dealer's choice for a little bit. If I put it on screen, not quite. That's enough. There we go. Let's go like that. Here's another one chat voted for. This is one where I think layout is everything. So I'm going to try and demonstrate, hopefully, how I would ideally lay this one out myself. I've had a go. We're given a fact with values n in there, and as we've seen a few times already, the thing that I would like to do is to get used to that fact by putting in different values of n. They say at the top there, for every integer n, this integral n to n plus 1 is equal to n plus 1. I can't really imagine that. I don't think I've ever seen that happen, that the integral would be so very simple, but hey, if they're telling me the value of the integral, I'm going to roll with that. So I'm just copying it out so that I can have split screen again. So they're telling me that fact for all values of n. I would like to try it out. And then I can see further down it says evaluate, and there's a sum from 1 to 8. But before I think about the sum, I would like to think about what the integrals inside the round brackets actually are. They involve the number r, so I think I'll have to remember a little bit that there is the context of a sum. R is something between 1 and 8 inclusive. But I would like to try and understand what those are inside the round brackets using the given fact. And then I'll come back and think about sums afterwards. We're just going to have sequencing, right? A little bit by bit. We will get to the sum when we get there. Right, okay, split screen. There are options. Do any of the options look interesting? 36, 84, 120, 165, 204, 288. None of those are sort of standing out to me, so I think we're actually going to have to do the question. What's the pity? Right, okay. There it goes. It sort of fits, doesn't it? Can I go one? No, let's go back there. There we go. Okay. I can have chat on as well, as long as I don't write there. Okay. Everything all at once? All of the real estate? Let's go. So let's see what happens. I know there's a sum coming, but I want to play with this first. I think 0 is the weirdest one, so let's try that. 0 plus 1 is 1. This would tell us that the integral from 0 to 1 of f of x is 1. Okay. Well, I can think of loads of functions that do that. I don't think I should try and solve for the function because I don't actually want to do all 8 of those integrals under there. Okay, what happens for what about n equals 1? Well, that gives me 1 to 2. Almost wrote 0 there, but that's also changing. This is an n here. How can I make that more obvious to myself? I don't know. I could stare at it a little bit. There we go. Okay, it's worked for me. N plus 1. So if n is 1, then this is 1 plus 1. 1 plus 1 is 2. Okay. So I've got integral from 0 to 1, and then they both changed. Integral from 1 to 2. Yeah, I don't know. Just trying out small numbers is sort of helpful for me because it forces me to understand what's changing as I change n, and maybe spot patterns. Like this one, I'm pretty confident it's 3 because I think this is going 1, 2, 3. Same as the top number, 1 more than the bottom number. I don't know. Is this useful? Who knows? What do we actually want? Well, we want something that says, oh gosh, the sum of some integrals. And I've told you I'm not going to think about the sum yet. So I'm going to think about what do I want then? So I want things like the integral from 0 to 1 of f of x dx, or the integral from 0 to 2 of f of x dx, because that's r equals 2 in the sum. Or maybe I want 0 to 3 f of x dx, or I'm not really thinking about adding these yet, but I do want to line them all up as things that I might want. 0 to 8. Okay, how are you supposed to integrate a function from 0 to 8 if you don't even know the function? Well, in some sense that's quite freeing, because if I knew the function, I would have to go and think about integration. I don't know the function, so I can't possibly have to go and actually think about how I'm going to integrate the function. I just definitely can't do that because I don't know it. All I've got is like armed with a stick or something like that. All I've got is these facts about small integrals from 0 to 1, 1 to 2, 2 to 3. I'm trying to read them out repeatedly to see if maybe someone watching us got the thing, which is that those are related. So if you want, 0 to 1, I've already got that one. That's 1. 0 to 2, I don't directly have this, but from integration, maybe I can imagine this. I'll draw a picture of what that thing might be. Ooh, goodness knows. Don't really care. 0 to 1, like this. 1 to 2, 2 to 3. These integrals are over different consecutive ranges. So this area here is the integral from 0 to 1, and then in a different colour, this one is the integral from 1 to 2, and then this one is the integral from 2 to 3. So if I want to go on that journey of working out the integral from 0 to 2, I should add the first two together. Integration is something like the area under the curve, more or less. It's not quite true, but it's definitely true that you can split the integral from 0 to 2 into two parts. integrating from 0 to 1 and integrating from 1 to 2. And you don't need to worry about whether the function is positive or negative, which is good because I've got no idea whether it's positive or negative. This is just always true for all functions f that you can integrate. Okay, great, which means that using the ones that I've got on the board, it's just 1 plus 2, just 3. There's a pattern here. Each integral that you want, you add on, it looks like, another bit. So I've got blue plus pink, and the next one is going to be blue plus pink plus purple, which will add on an extra bit. So for the next one, I'll actually need to use this one, previous one plus 3. So at this point, I think I laid this out by making a little table. So for the value of r, and you want the integral 0 to r of f of x. And I'm being really sluggish with getting to the point of actually adding these together. I think I'm going to find a formula, by the way. I've decided that 8 is not that big, and that I can just find all 8 of these if I want to. We've seen the first ones are 1 and 3. I've suggested that for the next one you would add on the next integral from the thing from 2 to 3, which gives you 6. And I love trying to spot patterns or trying to spot what's going on. So maybe I should let chat. No, Saddlers and chat has just got a number. Fine. I've seen that sequence before. Maybe you've seen that sequence before as well. If not, hey, try reading Pascal's triangle diagonally. These are binomial coefficients, but that's probably not what people think. But we'll think about, yes, brilliant. The integral of each one is r plus the, wait, hang on, is the r plus the sum of the previous ones? We've got a new section. How am I thinking of this? I've got the previous one plus the integral from 3 to 4, which f of x dx, which I have a rule for. So that looks awful, but it just means add top number, one more than the bottom number, add 4. So 10. After the next one, add 5, and then 6, and then 7, and then 8. And I would genuinely just work those out, spotting the pattern, and then just go and add them. I guess. Because life is short, and there's probably a clever formula or a clever way of writing down, I've done it. Each one involves a sum because I'm adding something each time. Now I want to add all of these. There's probably some clever formula, but life is short and adding numbers together is not that bad. Yeah. So if you like, if you write down a formula, Extreme Combinatorics has got one, and I think Rivik has got the same. This is, excuse me, so this is 1 plus 1 plus 2 plus 1 plus 2 plus 3 plus 1 plus 2 plus 3 plus 4 plus, and so on, 1 plus 2 plus dot 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 plus 8. And for some people, they want a formula for that. And probably it's time to bring all the strings together because it's 7:15. We've seen ideas for this before. This is a cubic sequence. It has an expression of this form. So if you want to repeat the sort of maths that we were looking at before, where we found the coefficients in terms of just knowing the first few terms, so here the first few terms would mean this and then this, adding on extra terms for, I suppose I want r instead of n maybe. No, I want, I don't know. What letter am I using to represent 8? Probably not r or n actually, but never mind. It's a sequence of this kind of format, cubic sequence, so if you want to repeat that sort of maths, you can do that. If you know about Pascal's triangle from before, let's keep that because there's like one idea. So one idea is you could use that style of maths to find a rule for the sequence. It goes 1 plus 3 is 4, 1 plus 4 plus 10 is 1 plus 4 plus 6 is 10, 1 plus 4 plus 10 plus 10 is 20. Alternatively, if you know that these numbers for summing together things are in Pascal's triangle, you could write out some of Pascal's triangle and you could try and find this pattern that we're looking at on screen somewhere in Pascal's triangle. So someone in chat mentioned Pascal's triangle earlier. You could try and find this sequence. Here it is. 1, 4, 10, 20. That keeps going. You can maybe try and work out why. Clue, this diagonal line here goes 1, 3, 6, 10, 15. Those are the triangle numbers. Because alternative, these are binomial coefficients, by the way. Oh, I'm writing off the screen. These are binomial coefficients, just to bring those in. So the answer to what's the sum of this sequence is just some binomial coefficient. 120 appears in Pascal's triangle somewhere. And third idea, just to link everything together, is that this represents the volume of a tetrahedron. If you make it stacked out of triangles, so 1 plus 3 gives you 4, plus a layer of 6 underneath gives you 10, plus a layer of 10 underneath that gives you a terrible picture of a tetrahedron, but gives you 20. So we mentioned tetrahedrons, I think, right at the start. Bringing it all together gives you lots of different ways to work out what this sequence is that goes 1, 4, 10, 20. It's all connected. I feel like that deserves a wow sticker, so I'm going to put a wow sticker over there. Good, right. Just finding other examples of ways to bring things together, so that if you want to loop it all together, you can. Connor's got a question about timing at the top there. I never really know. There is a time limit for TMUA overall. TMUA currently, I think the main fact about timing is that it is months away. And at the moment, I wouldn't really worry about timing at all. In particular, I wouldn't look at solutions to questions just because I felt that I'd run out of time. I would remain stuck on any questions that I was stuck on for at least, end of August, maybe end of September, before I sort of look at some solutions and think, yeah, I'm just going to get some learning out of looking at those solutions. Yeah, maybe September. Trying for speed, I think, just comes naturally. Finding lots of, ways to get quicker at doing binomial expansions. It's not fun, but if you're quick at doing binomial expansions, then it saves you a surprising amount of time. Last week we looked at some quick ways to do polynomial division. I tried to, not impressing anyone, but tried to show off by doing polynomial division quite quickly. If you can do stuff like that, then things just get faster. That frees up more of your time for having ideas. I have very few suggestions for how you have ideas faster. Tried to mention one earlier with the kind of switching gears, going forwards and backwards to try things in different directions. But having ideas for what you're supposed to be doing mostly just comes down to just trying stuff and trying stuff fluently. Right, sorry, Connor, I think you were expecting a short answer, like 3 minutes or something, but you got a long answer about structuring your entire summer. Sorry. Right, another one. Dealer's choice. We got 10 minutes. Dealer's choice, I think. Right, I want to talk about the sum of sine things because it's not particularly difficult, so I don't think people have voted for it. But maybe you have. Sorry, I shouldn't talk like that, should I? Maybe you voted for this, in which case, great. Good trigonometry practice, right? What's the value of these things? And it's using radians. Hooray! My favourite. So essentially, this is a periodic sequence. It's maybe the reason why I put a bullet point about periodic sequences on the sheet. Did I add it this year? Can't remember. It's related, right? Here's a periodic sequence. Spoilers, it's periodic. I mean, almost all of the options on screen there, almost all of the options really strongly suggest that it's periodic, right? These things about it being something to do with multiples of 6 comes up quite a lot. Multiples of 6 repeat, so do things that are one more than a multiple of 6. It's sort of a repeating pattern, which suggests that you could probably just check small numbers and see what's going on. Just sort of evaluate the sum. Have a go at piecing things together. It does say necessary and sufficient condition, but that really just means you want to find precisely the values that work. If it didn't say that, which of the following is a condition for this to work, then, well, awkwardly, some of them imply each other. So if you think that n being a multiple of 3 is necessary and sufficient. I don't think that's the right answer. But if you think B is the thing that's necessary and sufficient, then awkwardly option C would also be sufficient. If the truth is that you have to be a multiple of 3 and that's the only thing that matters, it's good enough. Any multiple of 3 in the club. I don't know why I'm now a bouncer for multiples of 3, but whatever. Any multiples of 3, it's in the club, and that's the only rule. It's necessary. You've got to be a multiple of 3. It's also sufficient. Any multiple of 3, welcome. So necessary and sufficient. Maybe that's the truth. In which case, option C, you see, that becomes sufficient multiples of 6. Well, you are a multiple of 3, so you shall pass. But it's not necessary. You don't have to be even. Bouncer analogy has really got out of control. So some of these, they have to say necessary and sufficient just so that you're not sort of looking for a sufficient condition, something that's good enough, and so that you're not, you know that you're looking for a necessary condition as well. You need to be. Right, okay, and Sadler's in chat has pointed out that you can sometimes just check small values of n, which is something we've done several times this evening, so glad to see that coming back again. N equals 1 is in some sense the easiest thing to check, because plugging in n equals 1 shows you, aha, on the left, we just have one term when k is 1, and it is sine of pi by 3, which, if you haven't met radians yet, the conversion factor is that radians are pretty large. Pi by 3 radians just means 60 degrees. So if you know sine of 60 degrees, it's root 3 over 2. Oh, great, my sum really is root 3 over 2. Sadler's points out this immediately eliminates options B and C because they don't include the case n equals 1. It doesn't, you see, we're not just done. If the question said which of these is sufficient, then A would be a legitimate answer because it's sufficient to just be the number 1. It turns out it has nothing to do with the multiples of 3 thing I was talking about. You've got to maybe do something else. Okay, n equals 1 is enough. If we can find another example, that might be more stuff along the way. Anyway, so if you do this, it's not that hard to work out values of sine. There's k pi over 3, but that's really not that bad because that goes from, I'll do it in degrees, it goes from 60 degrees to 120 degrees to 180 degrees, you know sine of all of those things, to 240 degrees, 300 degrees, 360 degrees, you know sine of all of those things. Maybe you draw a diagram like me, but you can work out sine of all of those things. In radians, you know pi by 3, 2 pi by 3, pi, 4 pi by 3, 5 pi by 3, and 2 pi. Those are all things that you would love to take sine of, and then things tend to repeat. There have been positive times for sine, there have been negative times for sine. You'll be unsurprised that those cancel out by the time that you get round to 2 pi or 360 degrees. Maybe you'll be a tiny bit surprised. Not that surprised, I think, especially if you drew a diagram. That the positive values are cancelled out. Negative values, you've got back round to 0, and just at that moment, sine has started repeating values again. So now it could be root 3 over 2 again. This is a long way of saying that it turns out that you want numbers like 1 and 4, and then it repeats 6 more later. Once you've done the whole go round, if you like. Those are 1 more than multiple of 3, which makes the answer D. I'm looking at my notes just to check I don't say the wrong letter of the alphabet more than anything. There is an extension on this, which is fun to think about. So I'm going to put it on the screen. We've got 5 minutes, but there was a request in chat to talk about the extension for this one. Oh yeah. Yeah, I don't know. Yeah, okay. I don't know if it rules out A and E that easily. Maybe if you start checking. So once you've noticed that n equals 4 works, that rules out options A and E, because now we've got a second example which shows that it's not necessary to be n equals 1, so A is no longer necessary. Okay, let's put solutions on, because I worked out how to do this. Pop. I think that works immediately for you, but it works very slowly for me because I then have to reset everything on my screen. Right. Ah, okay. Is this happening on Excel further pure? Right. Okay. Thanks, EJ. That's good context. Slightly awkward context in a way, right? It means that if you're doing Excel further pure, then you've seen questions like that. It's a small effect, isn't it? Anyway, right. I think we're now looking at solutions. Yes, we are. What a seamless transition. Said nobody. I also want to scroll down about 4 pages. If you get the worksheets on the website, which is down there somewhere in the description, you can also get the solutions page, which is our web page. You can view. Oh, there's my table of square roots of 3. Brilliant. Time to stop scrolling, I guess. Each question has got extension ideas. Some of them it's easier to think of extension ideas than others. If I'm being honest. But this one got some good ideas. At first, change the factor to pi over 2 or pi over 5, just to kind of check your understanding and check, does this affect where the sequence settles down to periodic behavior? If I change the factor in the question, does this settle down? But then I think the natural question is, what if that factor is just 1? What if we're just adding together sine of whole numbers? And there's a brilliant way to do this. That maybe I'll demonstrate, because it's not. I haven't published solutions for the solutions. So in some sense, if you want a solution for an extension activity, then you kind of have to turn up to the live stream and ask me. And then it is an interesting challenge to see what I can do about that. Okay, so spoilers for the extension. You should try it. I don't think pi over 2 or pi over 5 are that exciting. Mostly this was an excuse for me to put the kind of fun question of is sine 1 radian plus sine 2 radians plus sine 3 radians plus sine n radians ever equal to 0? Intuition in chat? Could do a vote. We've only got 5 minutes. Let's not set up a new vote now. Intuition in chat? Radian's a weird amount of angle in some sense. What is it, about 57 degrees or something mad? So as you go round, you get around to 6 radians, and that's not a full rotation. 7 radians is too large. But then maybe if you keep going around again, you don't get to 0 then either. Pi is irrational. So in some sense, as you're adding these up, you're not going to repeat values, but maybe, even though the values don't repeat, maybe they just all sort of add up to exactly 0. Maybe there's some nice value then, like 39 or something, where you just add all of this together and it just all cancels. Not pairwise and not each term being exactly negative something else, but just all of it adds together to give 0. Maybe. I think you can maybe tell from my tone that I find that unlikely. And there is a way to do this sum, which reveals that the answer is no, this is never equal to 0. And now, ideally, I would remember how to do this. So the hint that I gave you is to multiply by sine 1/2 and use double angle identities. I've put hard on this. Double angle identities are not on TMUA. Let's not worry about it too much. There's a way to simplify this first bit. Let's do that first. So, using the hint, I suppose, sine 1/2 sine 1 plus sine 1/2 sine 2. There's a rule for sine A sine B, which for some people is in the formula booklet. I don't know if you get the same sort of formula booklet that I got when I was in school, but if you've got one, then you've got access to some formulas, I suppose. And one of them is something about these sine, because this sort of thing turns up in the formula booklet, depending on what's in your formula booklet. Sorry. Do people still get a formula booklet? Oh, thank you, Violet, for solutions. There you go. Yeah, probably not. Yeah, I'm sampling points in a circle, going round and round, equal jumps of 1 radian. Radian's a weird amount. So this is cos A cos B plus sine A sine B. And also there's facts like this with a plus sign in the middle. I think I'm going to run out of time before I do this, which is really annoying. So you can do the difference. The reason I'm doing this is, well, because I want to, but the reason I'm doing literally this is that minus sign is not guaranteed to be correct because I'm now rushing. You still get formula booklets, good. I wonder how much of this stuff is in formula booklets. The reason that stuff like this is quite nice for questions like this is that you get, instead of some products that you're adding, you get reasonably predictable terms with a minus sign in, and my eyes light up when I imagine adding together lots of things where half the terms have plus signs and half the terms have minus signs, especially if I'm aiming to get 0. Maybe this will be 0. Let's find out. Okay, so I've got rules like this. Goodness knows. If you want past or similar computer science interview questions, there is a link on the homepage. There's one of the few things, there's a brilliant question, but one of the few things that is on the homepage. You do have to scroll all the way down, so I will forgive you for that. But if you scroll all the way down, you can find my colleague, Varun Kanadi, has a blog with 6 examples of questions that they've used in interviews or their colleagues have used in interviews with some working out and discussion. It's good stuff. Right, okay, I've got this fact. I have things like this. I want things like this difference of cosines. Let's see if I can get that right. Come on. So this is going to be something like cosine 1/2 for the difference between these numbers minus cosine 3/2 for the sum divided by 2. And this next one, okay, I multiplied by sine 1/2 to get these terms, to get these products of sines. And this next one is cosine of 3/2 for the difference minus cosine of 5/2 for the sum, and there's a plus sign in between. And now we're really in business because there's some cancellation, and I'm out of time. I think that keeps happening. You can simplify this sum not to 0, but you can simplify this sum a lot with that weird extra factor of sine 1/2. You can simplify this sum up to n by crossing out almost all of the terms. There's loads of cancellation. It's brilliant. The thing you're left with is definitely not 0, but I'll leave that as an exercise, I think. Right, okay, I think I'm hitting the ejector seat button midway through a question, but fair enough, I've got to find out whether it is sufficient to own a train ticket because I've got to go and get a train. Right, sorry to end abruptly, but hopefully I've shown you enough ideas that you can maybe you can piece this together for me. This first one is non-zero because these things do not add up to 0. Proof by finding another fact which lets you combine cosines back together again afterwards, right? So if after all your cancellation you're left with something like this left-hand side, you might want to convert it back into the right-hand side because checking whether things are equal is all well and good, but checking whether a product is equal to 0, that's what the real fun is. Right, good. Most of it's new. Right, okay. Show us chats. Brilliant. Great. GCSE test. Okay, cool. Right, okay. I think I'm wrapping up there. Sorry for the slightly panicked and rushed attempt to do a bonus extension question. I think what I've demonstrated is that there are hard questions in there for follow-up. I'm trying to make sure that everyone has got some extra maths to think about, whether you're in year 10 and you've just met some of these topics, learning about new stuff, whether you're in year 12 or equivalent and you're going to learn about sequences at some point, or whether you are me, it turns out, capable of writing a question and then forgetting the answer. I get some maths to think about too. Fun. Right, okay, thanks everyone. Thanks for joining in and voting and all of that. I will see you again in 166 hours for another episode of the Oxford Maths Admissions Test live stream. I got the name right. There we go. Right. See ya. Bye.